So we're going to continue on with dilations. We've already talked about what a dilation is, what scale factor is. Now we're going to apply some numbers to all of that. You will notice here how it has a D and then the coordinate XY. That just tells you a dilation is happening onto a coordinate. Okay, this is just like a notation for dilations. And what's actually happening is I am multiplying 1.5 times all my X coordinates and 1.5 times all my Y coordinates. Okay, that's the dilation that we're actually performing. So before we even do any dilation, here's our points G, H, and J. I would like you to graph those points on your coordinate plane. So graph triangle G, H, J. So your triangle should look something like that. Now before I do anything, it says I'm going to multiply by 1.5. That's going to be my scale factor. So if I have a scale factor of 1.5, what should happen to my pre-image? It should get bigger, right? So when I figure out what my coordinates are, I should have an enlargement. That should happen. So this is a nice self-check. If you know what's supposed to happen and then it doesn't happen, that either tells you graphed wrong or you did your math wrong somewhere. Okay? Now here's how we're going to find the coordinates of G prime, H prime, and J prime. I am literally going to plug in my X value for G here for the dilation, and that's going to be my new X coordinate. So 1 times 1.5 is 1.5. I'm going to do the same thing with the Y coordinate. Negative 2 times 1.5. So a calculator might be handy. What is negative 2 times 1.5? Positive 3? It should be negative 3, right? Negative 2 times 1.5 is negative 3. I'm going to do the same thing for H. 1 times 1.5 is 1.5. Negative 4 times 1.5, negative 6. Okay, last thing for J. 1.5 times 4 is 6. 1.5 times negative 2 is a negative 3. So here are your new coordinates for your image, your G prime, H prime, and J prime. Okay, we're going to plot those points. So 1.5, negative 3, 1.5, negative 6, 6, negative 3. So if I look at my new triangle, did an enlargement happen? Yeah, that's what's supposed to happen, so we should be okay there. What was my scale factor? 1.5. Now we like to write it as a ratio, okay? Do you agree that 1.5 is the same as 1.5 over 1? Does that mean the same thing? Yeah, right? I can put it over 1. Now how would I change that? Because like I did in homework, I didn't like that decimal. How do I get rid of that decimal? Multiply both the top and bottom by 10, so that gives me 15 over 10. What is 15 over 10 reduced to? 3 over 2. So 1.5 is the same as 3 over 2, but we want it as that fraction because we're writing ratios. Are we okay with that? Okay, so I'm going to have you do number 2. You're going to do the exact same thing. I want you to graph. What should happen based on the dilation you see, though? What's the dilation? What's the scale factor? It should get smaller because my scale factor is 1/3, right? So it should be a reduction. So take a second, you can work with your group if you'd like, and graph your pre-image, find the coordinates of your image, and then graph that as well. All right, can someone give me the coordinates of L prime based on the dilation you performed? -1, 1. Okay. Someone else give me the coordinates of M prime? 1, 2. And what about N prime? 1, -1. Everyone okay with those coordinates? Okay, so when I go to plot those points, let's see, -1, 1. 1, 2. Did a reduction occur? Yeah. And what's my scale factor? 1/3. It's already as a ratio, so I don't have to do anything else. Are we okay with all of that? Okay. Go ahead and cross out 3 and 4. We're not going to talk about center of dilation, but we are going to look at number 5. So number 5 says fill in the lengths. If I'm asked to find the length of something, what do I potentially have to use? The distance formula. Do we remember the distance formula? Yeah? Someone tell me what it is. Square root of x2 minus x1 squared. Okay, so a couple of us know that. So it was on your first test. I guarantee it will be on this next one. So you need to know the distance formula. Okay. So fill in the lengths of the segments in problem 1. Express each as a ratio. I can't even read. Express each ratio as a decimal. Okay, so it tells us here to find G prime, H prime. Now, I would use the distance formula. However, if you look at that triangle, what's nice about it? What's nice about G prime, H prime? Do I need the distance formula? Why? What kind of line is it? It's a vertical line, right? It's exactly on the boxes, so you can count the boxes. So take a second and count how many boxes is G prime, H prime. What do you get? How many boxes is G prime, H prime? What's the length? 3. We're just counting the boxes of G prime, H prime. So if you count, it's 1, 2, 3 units long. So G prime, H prime is 3. What is the length of GH? 2. And what is 3/2 as a decimal? 1.5? Okay. Careful with this next one. What is the length of J prime, G prime? Remember, it starts at 1.5 and ends at 6. 4.5? I heard 4.5. What's the length of JG? No, that one's on 1 and 4, so that should just be 3. Now, I don't like that decimal. How would I change it? Multiply by 10. So that's 45 over 30. And what does that reduce to? What's the biggest number that goes into 45 and 30? Higher. 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 15. 40 or 15 goes into 45 3 times. It goes into 30 twice, which is the same as 1.5. Now, if you didn't get 15 right away, which we didn't, right? Because I said higher like 5 times, that's fine. Reduce it with the number that you know, and then you just have to make sure you reduce it to its simplest form. Do you notice anything about what these ratios and decimals are? Because remember, we're technically using the information from problem 1. Do you notice anything? It's your scale factor, right? Wasn't our scale factor for number 1 1.5? These are also 1.5, and they should be, because we said that side lengths have to be proportional, okay, which means they have the same scale factor that we used initially. So on number 6, if we're referring to problem 2, what should all of the answers for number 6 be? It should be 1/3, right? Now number 6 is not as nice because we don't have a ton of vertical lines here, so we do have to do some work. So we're going to break this up a little bit. Okay, so groups A and B. I would like you to find the distance. Okay, so groups A and B. I need you to find the distance of L prime, M prime. So group A and B, find L prime, M prime. You're going to have to use the distance formula. Group C and D, find the distance of LM. C and D, LM. Group E, you have a little bit extra work, but yours isn't as hard. I want you to find this whole fraction. So I need you to find the distance of M prime, N prime, and MN, but you don't need to use a distance formula. Just look at the graph. Okay? F and G, you're going to find N prime, L prime. F and G, N prime, L prime, and H and I, you're going to find NL, the distance of NL. Okay, so everyone take a second with your group and just find the one thing you're looking for. Groups A and B. If you get a radical, again, simplest radical form, groups A and B, what did you get for L prime, M prime? Someone from groups A and B? What did you guys get for L prime, M prime?
Wouldn't it be 2?
You took 5 and reduced it to 1? The answer is the square root of 5. If you use the distance formula, okay, so a lot of people keep telling, and this has been in every class, a lot of people keep saying their answer was 5. There is a huge difference between 5 and the square root of 5. Yeah, it's 2 point something. There's a huge difference. So you need to make sure that if there is a radical in your answer, it stays there unless it completely simplifies out. It's a perfect square. Okay? Groups C and D. What did you get for the distance of LM? Simplest radical form. 3 square root of 5. Did you guys get the same thing? Okay. So LM was 3 square root of 5. Is there anything that can cancel? The square roots of 5 cancel out. So if you have nothing left on top, you really have a 1. Because the square root of 5 divided by the square root of 5 is 1. And then 3 is on the bottom. Isn't that what we were supposed to get? Right? That's our scale factor. Okay, group F. No, E. What'd you get for M prime, N prime? Okay. Well, you can't simplify yet. What'd you get for MN? 9. Okay, so M prime, N prime was 3. MN is 9. Now it can reduce to 1/3, right? Groups F and G. What'd you get for N prime, L prime? When you use the distance formula. Groups F and G. What'd you get? Go ahead, Kendall.
For N prime, L prime, the square root of 8.
Okay, so we have the square root of 8. Can that be simplified at all?
Yeah.
Right, to 4 and 2 and 2 and 2. So you have a pair of 2's. So it's 2 square root of 2. Remember, we want it in simplest radical form. What about H and group HI? What'd you get for the distance of NL? What'd you get when you used this distance formula? Okay, so is the square root of 72 simplified? No. What multiplies to 72? 9 and 8, 3 and 3, 4 and 2, 2 and 2. Simplest radical form. We talked about this in the last unit. Remember, you have pairs of 3s and pairs of 2s. Those pairs come out. 3 times 2 is 6. And what's left over? 2. What cancels here? The radical 2's. Does 2 over 6 reduce? To 1/3. Not right now. Okay. So there were a lot of groups who looked like they didn't do this. I don't know if it was we didn't know how to use a distance formula. I don't know if you weren't confident in your answer. I don't know if it's because you can't simplify a radical. But you need to attempt to do the problem. So when I give you a problem to do, I expect that you try it. Okay? I don't care if it's wrong, but I want you to try. You're never going to learn if you don't try. Questions on this front side? Okay. The back side's going to be your homework, but I do want to look at it real quick. First of all, you are not doing problems 4 through 7. So you can cross off 4 through 7. Shh. I need everyone to pay attention. Okay. So looking at problems 1 through 3. It is exactly like 1 and 2 on the front. So you're going to need to graph the pre-image. You're going to need to apply the dilation, and then you should graph the image. Okay? Now I want you to look at 2 because 2 looks slightly different than the ones on the first page. You'll notice that the dilation says 2 times x plus 2. And y is 2 times y minus 3. Okay? We are doing the same thing, so I'm going to help you with j prime. You are going to take x and plug it in for x. So negative 2 plus 2 is 0. 0 times 2 is 0. Oh, goodness. We're going to do the same thing for y, but you're plugging it in for y. 2 minus 3 is negative 1. Negative 1 times 2 is negative 2. Do you see how we just plug those in? Okay, so that's all you're doing for 2 and 3. And again, you're graphing both the pre-image and the image. You can if that's easier for you. So if you'd rather have it say 2x plus 4 and 2y minus 6, I'm okay with that. I wouldn't do that necessarily though for number 3 because then you have a double fractions where if you just plug it in, you might be able to divide and still get a nice number. Okay? But either way is fine. Questions on what you need to do for homework? Okay.